Good afternoon to all of you. So, in the last class, I explained about the how to calculate principal stresses. I explained two methods. Actually, we learned about only one method. So today I'm going to explain in the remaining topics and maximum and minimum principal stresses. In the last class, I explained about the different types of cases. So in each case, we have to calculate different types of values. So in the last class, I explained to you what are the values we have to calculate here. First one is nothing but principal pain. Principal pain. Next one is nothing but a principal stress. Principal stress. And third one is shear plane. That is indicated by symbol theta s. It is sigma p. It is theta p. And next one is maximum shear. That is maximum shear stress. That is tau maximum. And last one is nothing but resultant stress. Resultant stress. So these are the five variables we calculated in the five cases. That is, what are the cases here? We know that the first one is nothing but the uniaxial state of stress. Uniaxial state, biaxial state of stress. Next one is nothing but a pure shear. Third one is uniaxial and shear. Next one is biaxial and shear. So these are the five cases we studied in the last class. In each case, we have to calculate principal plane, principal stress, shear plane, maximum shear stress, and resultant stress. I have already given to you what are the formulas are required to find these five variables in each case. I have already told you. Okay, right. So I have already given some problems on these cases. So uniaxial case is over. So I'm giving the some problems on biaxial state also. After that, I'm going to give the pure shear and uniaxial and shear and biaxial and shear. After that, I'm going to explain to you. So how many methods we have to calculate maximum and minimum principal stresses or maximum or minimum principal strains. There are two methods we can calculate the maximum and minimum principal stresses. That is, first one is nothing but analytical method. The second one is nothing but graphical method. That is all of you know very well. So that first of all, I'm going to give the different types of problems which are given in the GATE examination on these five cases. Please try to learn those problems. And after that, we have to practice those problems in any material or any uh, textbook. Then we can get the confidence to solve the problems. So that what I'm saying here today, I'm going to explain to you so how to calculate some problems on different types of cases now. So in the last class, uniaxial case is over, and I have given one or two problems on biaxial state of stress. So that today I'm also giving some problems on biaxial state of stress. After that, I'm going to give it to you some problems on different cases also, remaining cases also. Okay, so that listen carefully what I'm saying. Right. So this is the another example problem on biaxial state of stress. So when a component is subjected to two types of stresses like this. So the stress is equal to three times of sigma. It is also three times of sigma. And another stress is nothing but compressive. It is along y direction. It is given as sigma and it is sigma. So a component is subject to two normal stresses. One is said to be under tensile, so it is positive. So another one is said to be negative, that is along y-axis. So this problem is actually given in GATE examination. So what they are asking here? So here they are asking what is the What is the ratio between normal stress and shear stress on maximum shear plane? On maximum shear plane. So it is biaxial. We are getting also two shear planes and two principal planes. So question is, I am asking here, question number one. What I am asking here, listen carefully. What I am asking here, a ratio between normal stress and shear stress on maximum shear plane, maximum shear plane. And the second one, I'm going to give question number two. That is question number two. What what is the value of maximum shear? What is the value of maximum shear? So here I'm going to give you what is the solution of this one now. So how to find this solution of these two questions. So listen carefully here. So first of all, I'm going to find the what is the ratio between the normal stress and maximum shear plane. So in this biaxial, shear is maximum and theta is equal to how much? 45 degrees or 135 degrees. I have already given to you. So that is 0 degrees and 90 degrees. So that is nothing but principal place. But shear plane is 45 degrees plus 90. We can get 135 degrees. Both are perpendicular each other. But on 45 degrees plane, on 135 degrees plane, we are having same magnitude of shear, but direction is opposite. Or got my point? So both are having same magnitude, but directions are opposite on 45 degrees plane and 135 degrees plane, whatever it is. But here we know that already I have explained in the last class how to calculate the principal plane shear, plane maximum shear in different cases. So it is biaxial. In case of biaxial, what is the value of normal stress formula? Normal stress is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta. That is the value of normal stress. Now, if you substitute theta is equal to 45 here, then 2 into 45 becomes cos 90. Cos 90 is how much? Cos 90 is how much? 0. So the center value get cancelled. Got my point or not? When theta is equal to 45. So we are getting the value of sigma x plus sigma by 2. Or get my point or not? When theta is equal to 45 here, 2 into 45 cos 90. Cos 90 is nothing but 0. So the center value becomes 0. So here. But what is sigma x here? Sigma x is nothing but 3 sigma, which is positive. What is sigma y? Sigma is compressive. It is negative. So we're writing minus sigma divided by 2. That is, we get 2 sigma by 2. So 2 both are cancelled. We get the sigma is the value of normal stress on maximum shear plane. On maximum shear plane. This is a simple question, but we have to remember the formula only. At the same time, I'm going to find the value of shear stress. What is the shear stress value? Sigma x minus sigma y by 2 into sine 2 theta is the value of shear stress when the component is subject to biaxial state of stress. Or you get my point or not? Now take the theta is equal to 45 here. Sine 2 into 45 sine 90. Sine 90 is equal to how much? 1. Then I'm going to write it here. Sigma x minus sigma y by 2, that is equal to what is sigma x here? 3 sigma minus what is sigma y minus sigma divided by 2. Then minus into minus positive, we can get 4 sigma by 2. Then we can get how much? 2 sigma is the value of shear stress. But here he is asking, what is the ratio between these two? What is the ratio between these two? What is the ratio between these two here? This is nothing but theta is equal to 40. What is the ratio between these two here now? So sigma n is how much? Sigma. And what is tau value? 2 sigma. and sigma sigma both are cancelled. That ratio is equal to how much? 1 by 2. So this is the way of calculation of a ratio between the normal stress and shear stress on maximum shear plane. So this is the solution for first question. And at the same time, what is the value of maximum shear here? When the shear is maximum, so when the shear is maximum when theta is equal to how much? 45. So now tell me here, what is the answer for this question now? What is the answer for this question now? So when theta is equal to 45 degrees, so tau must be is equal to tau maximum. Tau must be is equal to tau maximum. But what is the tau value here? This is the tau value tau. So what is the maximum value? Tau sigma. Same in the same formula, I'm going to substitute what is the value of theta. That is theta is equal to 45. We get the same thing. Then substitute, we're going to get 2 sigma. So what I'm saying here, so this is the value of ratio between normal stress and shear stress. And this is the value of maximum shear. So in this way, we are going to calculate so different types of questions on the same problem. So here, this is the biaxial state of stress. Or you got my point? Right. I want to give it to you. So one more question. Please listen carefully here. Right. So here, one question is given in this NEET examination. So listen carefully. That is sigma x is given. Sigma x is given. That is 100 megapascals. How much is given? 100 megapascals is given. That is the tensile stress. This is positive. This is a tensile stress along x direction on a component. And sigma y is equal to 25 megapascals. 25 megapascals. Doesn't get it. So this is along y direction. But here, this y direction is negative. So it is a compressive stress. It is a tensile stress. This is the data is given in the gate examination on a simple stress, that is complex state of stress under biaxial state of stress. So in this case, he is asking one question, that is find the maximum shear in the component. The question is given, if sigma x is equal to 100 megapascals positive tensile, sigma y is equal to 25 megapascals negative, then find the value of tau maximum. Tau maximum. What is the formula for tau maximum? All of you know that. Tau maximum in biaxial case is nothing but sigma x minus sigma y by 2. Already I derived that one. Already I told you how to calculate tau maximum. Why? Because tau maximum is always equal to theta. Generally formula is tau maximum is equal to, that is sigma x minus sigma y by 2 into how much sine 2 theta. But tau is maximum when theta is equal to how much? 45 degrees. Or you got my point? So if you substitute theta is equal to 45 degrees here, then we are getting the sigma x minus sigma y. Now I'm going to substitute those values. That is 100 minus of 25, that is divided by 2. I'm getting here 100 plus 25 divided by 2. Then we can get 120 divided by 2. We can get here 62.5 is the answer. Or you get my point or not? Or you get it? Half of this one is nothing but 120 is nothing but 60. So 62.5 megapascals is the value of maximum shear stress. Maximum shear stress. So they will ask any type of question like this. Or get my point or not? So here, one more question is given in the gate examination. So please take care about that thing now. So here, one more question is given like this. Uh, these are the questions which are given for 1 mark. So this is the sigma x value that is equal to minus 100 megapascals is given, and sigma y is also given that is equal to minus 10 megapascals. So these are the two values are given in the question, the gate examination, but they are asking. So they are asking the question, find the what is the maximum shear stress in the component. So I am going to indicate this is the component. This is subject to both our compressive stresses, so along x direction, along y direction. So it is equal to how much? 100 megapascals. It is equal to 10 megapascals. So both are under compressive. So that I want to find the what is the value of tau maximum. So tau maximum is always equal to theta is equal to 45 degrees. That is always equal to sigma x minus sigma y by 2 when theta is equal to 45 degrees. We know that we have already know it, that formula in biaxial state of stress. But here, what is sigma x minus 100 minus of minus 10 divided by how much? 2. Then we can get minus 100 plus 10 divided by 2. Then we are getting here. So minus 90 divided by 2. Then we are getting minus 45. So megapascals. So minus positive is nothing but sign convention, whether it is positive or negative to the direction of action of the shear. But here we are having two shear planes, both are having same magnitude, but directions are opposite to each other. So this is the problem which is given in gate examination. Now I want to give uh, some more problems on all care, that is biaxial and shear case. After that, I'm going to give it to you uniaxial and shear case also. So there are five cases are there. One is nothing but now listen carefully. On this one, on the biaxial state of stress, I want to give one more problem. After that, I am going to give it some problems on biaxial and shear case. If you know how to solve the problems on biaxial and shear, then automatically we can solve all problems which are given in different cases. So here, so I'm writing like this. So listen carefully. In a biaxial state of stress, a component is sigma x is equal to 100 megapascals and sigma y is equal to so also 50 megapascals. Both are positive, both are tensile. Sigma x is equal to 100 megapascals, sigma y is equal to 50 megapascals. Are you get my point or not? So my question, he is asking the question, that is question number one. Find the find the normal stress and shear stress on a plane makes an angle of 30 degrees with vertical. What I am asking here, so find the normal stress and shear stress on a plane makes angle of 30 degrees with vertical. Or you got my point? Right. Now listen carefully how to solve this question. So for this one, so when the component is subject to biaxial state of stress, we know the true formula. Normal stress is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta. But he is asking at what angle we are going to find, at what angle of the plane we are going to find the normal stress value. We are going to find the normal stress on a plane which makes an angle of 30 degrees with the vertical, so that I'm going to substitute theta is equal to 30 here, sigma x can go into substitute here. That is 300, sigma x is 300 plus 50 divided by 2 plus 300, sorry, 100 here, not 300. That is 100 minus 50 divided by 2 into cos into 2 into how much? 30. Now here we are getting here 150 divided by 2 means 75 plus. So here is 50 to 25 into cos 60. Cos 60 is always equal to sin 30. Sin 30 is always equal to 1 by 2. Then we are getting here 75 plus, that is 12.5. Or get my point or not? That is 87.5. That is 87.5 we can get in terms of megapascals. So that is the value of normal stress on a plane which makes an angle of 30 degrees. We can solve very easy. Now I want to find the shear stress also. What is the shear stress value? Tau is equal to sigma x minus sigma y by 2 into how much? Sine 2 theta. That is sigma x is nothing but 100 minus 50 divided by 2 into sine 2 into what is the angle here? 30. So here I am writing 75 into that is sorry 50 by 2 that is 25 into that is sine 60. Sine 60 is how much now? Root 3 by 2. So I can write here 25 into root 3 divided by 2. Then I am writing here 12.5 into root 3 times of megapascal. So this is the value of shear stress. This is the value of normal stress on a plane which makes an angle of 30 degrees in the vertical plane. Or you got my point? Right. Now I'm going to give it to you some more problems on different cases. That is, two cases are very clear. That is nothing but the first one is first one is uniaxial and biaxial is over. So the remaining is pure shear and uniaxial and shear and biaxial and shear. So first of all, I'm going to explain biaxial and shear. After that, I'm going to explain uniaxial and shear. And pure shear also. Shear is very simple. Pure shear means we have to use the only two formula. Then we can take the things now. Right. So here I'm going to explain to you that is biaxial and shear. So I'm going to take the case biaxial and shear. So listen carefully. So on this one, so many questions are given in GATE examination. So please take care about that one. So I'm taking here first example problem. So listen carefully. So here, uh, question is given like this. Any one of the any one of the principal stress is zero. What I'm saying, any one of the principal stress is zero. Then find the value of find the value of tau xy. Find the value of tau xy. Four options are given. Option A, that is sigma x into sigma y. Option B, sigma x divided by sigma y. And option C is given sigma x plus sigma y. And option D is given square root of sigma x into sigma y. So these are the value options are given for this case. So what is asking now? So any one of the principal stress is zero, then find the value of tau xy. Find the value of tau xy. So take care about the question. Now I'm going to give the solution for this. So listen carefully here. So actually, when the case is not given to you, so you have to take always biaxial shear. In case of biaxial shear, that is the standard case. So by using the standard case, we can apply the conditions I have already given. So when sigma x is 0, sigma y is 0, only tau xy. I have already told you in a table. So be careful about the table. Then we can identify which case it is. Then automatically we can find all those five variables. That is principal plane, principal stress, shear plane, shear, maximum shear. We can find any value. So here I am going to take actually any one of the principal stress is zero, but when the component is subject to biaxial and shear, so but here is case is not mentioned. So we have to take the standard case. So in this problem, case is not mentioned. Case is not mentioned means whether it is belongs to uniaxial or biaxial or uniaxial and shear or biaxial and shear not is not mentioned here. So we have to take the standard case, that is biaxial and shear case here. So in case of biaxial shear case, what is the maximum and minimum principal stresses? Sigma P1 and sigma P2 is equal to sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. So this is the formula for maximum and minimum principal stresses. So if you take a positive, we can get maximum principal stress. If you take a negative, we can get the minimum principal stress. Now here, what is the question is given? Any one of the principal stress is zero. So here two principal stress. We can take any one, either maximum or minimum. So I am taking maximum here, or we can take minimum or minimum also, as you wish. So I am taking maximum here. So sigma x plus sigma y by 2 plus square root of sigma x minus sigma y by 2 whole square plus tau xy must be equal to 0. He is saying like this, any one of the principal stress is 0. Then what happen here? If you bring this term to this side, then we are getting like this. That is sigma x plus sigma y by 2 is equal to minus of square root of sigma x minus sigma y by 2 whole square plus tau xy square. So if you're squaring on both sides, squaring on both sides. So here this negative get cancelled, root is get cancelled. Then I'm writing here sigma x plus sigma y by 2 whole square is equal to sigma x minus sigma y by 2 whole square plus tau x square. Now you got my point? Now here I want to find which value, what is the value of tau xy? So I am telling very slowly, but we have to calculate very fast in GATE examination. By practicing it only, we can calculate such type of problems very fast now. So that I'm going to give it to you. So how to find that value now? How to find that value? Now tell me here. So here I am writing sigma x plus sigma y by 2 whole square minus sigma x minus sigma y by 2 whole square is equal to tau x square is equal to how much? Tau x square. Now then we are going to find the value what is tau x square, or get my point or not. So if you expand this one, we can get here sigma x square by 2, that is 4 we are getting, or got my point or not? Right? So we can separate those things, plus 4 plus sigma y square by 4, that is a plus b whole square, a square plus b square plus 2 into sigma x into sigma y by 2 into 2. Got my point or not? Right? So minus, same we are getting here, sigma x square by 4 minus, that is sigma y square by 4 plus we are getting 2 sigma x into sigma y by 4 we are getting. So this term, all terms are getting cancelled. Or get my point here. So this is 4, and take a 4 LCM. Then we are getting the value like this. That is equal to tau xy square. So if you expand this one, then we are getting here. So sigma x into sigma y, we can get it. If we add these two terms, is equal to how much? Tau xy square. That implies tau xy is equal to how much? Square root of sigma x into sigma y. So this is the way of calculation of. So what is the value of tau xy? If any one of the principal stress is 0. Have you got my point? Have you got my point? All right. So here, one more question is given in the GATE examination. Please take care about those things. All right. So here, one more question is given in the GATE examination. So like this. So this is the sigma x value. So sigma x is given minus 40 megapascals, and the sigma y is also is given, that is sorry, plus 40 megapascals, and the sigma y is 100 megapascals, and tau xy is given as tau xy is also here. I'm going to write tau xy is equal to 40 megapascals. Tau xy is equal to 40 megapascals. So here the question is given in gate examination. The question is given in gate examination. Find the value of maximum shear stress. Find the value of tau maximum. So this case is directly given, that is biaxial shear. So in case of biaxial shear, what is the formula for tau maximum here? Tau maximum is equal to square root of, we know the formula, sigma x minus sigma y by 2 whole square plus tau xy square. I got my point? Sigma x minus sigma y by 2 whole square plus tau xy whole square. So here substitute those values here, that is 40 minus 100 divided by 2 whole square plus, or got my point, plus tau xy is nothing but 40 square under square. Then we are getting the value of, here is 60, 60 by 2 means 30, that is we can get 30 square plus 40 square under square root. Got my point or not? Then we are getting the value of tau maximum. Or get my point or not? Right. So here we can easily calculate like this. So here I'm writing here, listen carefully. Uh, that is 30. 30 we can write like this, 30 into 10 whole square plus 4 into 10 whole square. So under square root. So here 10 square is common. 10 square we can bring the comma outside, then we can write 10 is common into square root of 3 square plus 4 square. Then we can get here 10 into how much? 5. Then we can get here 50 megapascals is the value of tau maximum here. Now you got my point or not? You got it? Right. So here, this is the one example problem on this by Excel and shear step, which is given in gate examination. And one more question is given in gate examination. Please take care about that case also. Now listen carefully here. Listen carefully here. So the question is given like this. So this is the diagram is given in gate examination. This is the diagram is given. So this is the horizontal plane. This is the vertical plane. So on that plane, one stress is given, that is 8 megapascal, that is tensile. And here one shear is given, the shear is given 3 megapascals, that is parallel to the surface. And here one more, this one is given, that is, this is the value, that is the normal stress to this plane. This plane makes an angle of how much? 45 degrees. Listen carefully. This plane makes an angle of how much? 45 degrees. Okay. Right. This is also 45 degrees. So this is the plane here now. Okay. This is the plane is given. Right. So on that plane, shear is also given. Here is equal to how much? 3 megapascals. And this is given 2 megapascals. So this is the question is given to you. So, but here they are asking the question, determine the two principal stresses. He is asking two principal stresses. So, which case it is? Tell me now. So it is uniaxial, biaxial, biaxial and shear, shear. Which case it is? First of all, you have to identify this case. So here, this is the oblique plane. This is horizontal, vertical plane. This is horizontal plane. Now, can you find this is the value of sigma x? I'm writing this is the value of sigma x. This is the value of tau x. We don't know what is the value of sigma y. If you know the sigma y, it is becomes a biaxial shear case. So here, this is the normal stress is given on any plane. This is oblique plane, which makes an angle of 45 degrees with vertical. So this is normal stress on the oblique plane. This is the shear stress on the oblique plane. Now, by using these two, I can find the sigma y value. I can find the sigma y value. What is sigma y value? So I am writing here. So in case of biaxial and general case, sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy into sin 2 theta. Or you get my point? But what is the theta is given? Theta is equal to how much? 45 degrees is given. So substitute all those values here. What is sigma normal stress here? Normal stress is given as 2 megapascals is equal to sigma x is nothing but 8 plus sigma y by 2 plus sigma x is nothing but 8 minus sigma y by 2 into cos 2 into 45 degrees plus tau xy into sine 2 into 45 degrees. Or you got it? Then what happened here? So 2 into 45 in cos 90 becomes 0. So this value becomes 0. Its value becomes 0. But what is sine 90? Sine 90 is equal to how much? So in case of tau xy, what is the value of tau xy? That is 3 megapascals. So here I am writing this remaining. That is 2 is equal to, this is 2 is equal to 8 plus sigma y by 2 plus, so 3 into sine 90. Sine 90 becomes how much? 1. So I'm writing here 2 is equal to 8 plus sigma y by 2 plus 3 into 1. Then I'm writing the value. So here, so 8 plus sigma y by 2 is equal to 2 minus 3. Then we can get the minus 1. So I'm writing here 8 plus sigma y by 2 is equal to minus 1 into 2. We are getting the minus 2. That is 8 plus sigma y is equal to minus 2. Sigma y is equal to how much? How much here? Tell me. That is nothing but minus 2 minus 8. Then we can get minus 10 megapascals. Minus 10 megapascals. After finding the sigma y, then automatically we can use the formula of maximum and minimum principal stresses formula. So after finding the y value, so what is the value of maximum and minimum principal stresses formula in the biaxial and shear? We know the formula very well, then substitute, then we can get the maximum and minimum principal stresses. What is the maximum and minimum principal stresses? Sigma P1 and sigma P2 is equal to. So sigma P1 and sigma P2 is equal to what is the formula? Sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau xy whole square. So substitute all the values here. What is sigma x? 8 megapascals. Sigma y is nothing but minus 10 megapascals. Divide by 2 plus or minus substitute those values. Then take the positive value, we can get the maximum principal stress. Take the negative value, we can get the minimum principal stress. So in this way, we can calculate maximum and minimum principal stresses for any case. You get my point or not? Or you got it? Right. So this is the way of solving the problem. So, but here in this problem, there is no sigma y value, but normal stress and shear stress on oblique plane is given, so that by using the normal stress formula, shear stress formula, we can calculate the sigma y value. So by using the sigma x, tau xy, then we can calculate maximum and minimum principal stresses on a plane, which makes an angle of 45 degrees. Or got my point or not? Right. So this is the another example problem which is given in GATE examination. So one more question is given like this. So please take care about this thing now also. So this is the value is given. Listen carefully. I'm going to give it to sigma x is given. Sigma x is equal to sigma y is equal to so tau xy. This is the case is given. All are same. All are same value. So sigma x equal to sigma y is equal to tau xy. So that means all values are same. So this is belongs to biaxial and shear. So this is equal to sigma x, sigma x. This is sigma y. And here I'm going to indicate that is tau xy. So tau xy. So this is also tau xy. So all are equal. So he is asking the question on this one. This is the given question. He is asking on this one, find the maximum and minimum principal stresses. find the maximum and minimum principal stresses. So in this case, how to calculate maximum and minimum principal stresses? We know the general formula, that is maximum and minimum principal stresses in case of biaxial and shear, that is sigma x plus sigma y by 2 plus or minus square root of sigma x minus sigma y by 2 whole square plus tau x by square. Or you get my point? So substitute here now. So for example, all are same. So I can convert all into sigma x or all into sigma y, all into tau xy as you wish. But we have to give this solution depending on the options, whether it is given in sigma x or sigma y or tau xy. So here I'm going to convert all values in terms of sigma x. So here sigma x plus sigma y is also is equal to sigma x divided by 2 plus or minus square root of. If you substitute sigma x both are cancelled, get cancelled here. So tau xy is also is equal to sigma x. Why? Because sigma x, sigma both are same here, both are cancelled to each other. Then here tau xy I am taking is also is equal to sigma x. So here what is the value we are getting here? That implies 2 sigma x divided by 2, 2 both are cancelled plus or minus sigma x square. So we are getting the value sigma x plus or minus again sigma x. Why? Because square and root both are cancelled. So here, if you take positive, I'm getting maximum principal stress. So maximum principal stress is equal to 2 sigma x and minimum principal stress is equal to 0. Is equal to how much? 0. So this is the way of calculation of maximum and minimum principal stresses. Or you got my point? Or you got it or not? Right. So this is the way of solving this problem. So one more question I'm going to give it to you. So this is the case for this one. So listen carefully. Most of the cases they are asking the question on maximum and minimum principal stresses in a component. So that take care about that thing. So some cases they will ask the question, what is the shear plane angle? What is the principal plane angle? They will ask you. So depending on the different conditions, we can find that value. So here, one more question is given in gate examination. So that is sigma x is equal to 200 megapascal. This is question is also given in gate. And sigma y is equal to 100 megapascals. Both are tensile. And tau xy is equal to 100 megapascals. This is the question is given. So here a question is given here like that. So he is asking what is the value of tau maximum value? What is the value of, see this, observe the questions how they are asking questions on principal stresses now. So there are different types of cases. So if you know the all cases, we can calculate each and everything. So what is the formula? Generally, all of you know it. That is the square root of. In case of biaxial and shear, we know that sigma x minus sigma y by 2 whole square plus tau xy whole square. Simply we can solve it. This is the solution. How to find the tau maximum value? Find the tau maximum value. So substitute that is 200 minus 100 divided by 2 whole square plus 100 square, 100 square. So it is also 100 by 2, that is nothing but 50, we can get it. 100 by 2, nothing but 50. So 50 square plus how much? 100 square, 100 square. Then we can get the value of tau maximum. So we can substitute this value in calculator, then we can get the value. We can got it. Okay, right. So right? So this is the case of biaxial shear. So I want to give one more question on this one. So biaxial shear. So listen carefully. Right. So this one. So this case is given like this. So you can write like this. So this is one plane. The plane having sigma x value. This is plane is also having sigma y value. So it is having tau xy value. So it is also having tau xy value. Both are having same magnitude, but directions are opposite. So this is the two mutual perpendicular planes. And what is the angle between the two mutual perpendicular planes? That is equal to 90 degrees. So he is asking question on this one. He is asking question on this one like this. So find the sum of the two normal stresses on two mutual perpendicular planes. What is the question is given? So listen carefully. I'm going to give the question. So here, so sum of two normal stresses on two mutual perpendicular planes. On two mutual perpendicular planes. So this is one plane, this is one plane. So both are perpendicular to each other. He is asking question sum of the two normal stresses on two mutual perpendicular planes. So it is also belongs to which case now? Biaxial and shear. So in case of biaxial and shear, what is the normal stress formula? What is the normal stress formula? Normal stress is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy into how much sin 2 theta. So this is the formula of normal stress on any plane when the component is subject to by excellent shear. All of you know very well. Or you got my point or not? Right. So here, what is asking sum of the two normal stresses on two mutual perpendicular planes is asking. So what is the normal stress? He is asking normal stress here. So what is the angle of the plane here? So one angle is nothing but how much? Zero. One angle is how much? How much? 90 degrees. So I'm taking this is 0 degrees and this is 90 degrees plane. We can take 0. This is 90 degrees as you wish. So I am substituting when theta is equal to 0, we can get one normal stress on this plane. Or get my point or not? When theta is equal to 0, this is one plane which is having angle is equal to 0. On that plane, we have one normal stress. The normal stress is sigma n1 is equal to, now tell me here, that is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 into 0 plus tau xy into sine into 2 0 degrees. So I think this value becomes 0. That value becomes 0 and this value becomes 1. Then how much value you get it? That is sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. Y both are cancelled. We get 2 sigma x divided by 2. We can get sigma x. Now I am writing when theta is equal to 90 degrees, then the stress, normal stress on the plane is nothing but sigma n2. But what is the angle between these two planes? 90 degrees. Both are perpendicular to each other. So here sigma n2 is equal to, so substitute in the same formula, theta is equal to 90. So I'm writing here sigma x plus into sigma x minus sigma y by 2 into cos 2 into 90 plus tau xy into sin 2 into 90. So here cos 90 is nothing but here is sin 180 all automatically 0. We know that sin 180 is also 0. So this star value is also 0. But here 2 into 90 is nothing but cos 180. Cos 180 is nothing but minus 1. Cos 180 is minus 1. So I'm getting here sigma x plus sigma y by 2 plus sigma x minus sigma y by 2, which is into minus 1. If you multiply with minus 1 inside, then we are getting here sigma x both are cancelled. We get only sigma y. So 2 sigma y divided by 2 both are cancelled. We are getting sigma y. Now tell me here, what is the answer for this one? Sum of the two normal stresses. I am giving a more analysis of this one, but here we can solve this problem with two steps only. Substitute theta is equal to 0, substitute theta is equal to 9, then we can get the value directly. So we will solve this problem within 1 minute. Or got my point or not? So listen carefully. So sum of the two normal stresses on two perpendicular planes is so sigma n1 plus sigma n2 is equal to sigma x plus sigma y. So this is the value of sum of two normal stresses on two mutual perpendicular plane. That is sigma x plus sigma y. Are you got it? Right. So this is the way of calculation of maximum shear principal stresses. The principal plane also we can calculate it. So that is tan 2 theta p. That is so you know the formula. So maximum they are asking questions. What are the maximum and minimum principal planes in biaxial and uniaxial and lattice? So for example, in case of uniaxial and shear. So for example, I am taking here uniaxial and shear. Excellent shear. So they will give the questions like this. So sigma x is equal to 50 megapascals and tau xy is equal to how much? 25 megapascals. Find the maximum and minimum principal stresses. Find the maximum and minimum principal stresses. So how to calculate maximum minimum principal stress in this uniaxial state of stress? We know that very well. So that is a sigma P1 and sigma P2 is equal to sigma x by 2 plus or minus square root of sigma x by 2 whole square plus tau x by whole square. Now substitute those values, take positive and take negative, then we can get the value of maximum and minimum pass. That is nothing but 50 divided by 2 plus or minus, that is square root of, so 50 divided by 2 whole square plus 25 square. So here 25 plus square root of 25 square plus 25 square. Then we can calculate this value. So first of all, we have to take the positive value. Take the positive value. So a square plus a square, that is nothing but 2a square. That is 2 times of, or get my point on. So here, so we can solve this one. We can take positive, then we can get the maximum principal stress. Take the negative value, we can get the minimum principal stress. So in this way, we can get the value of maximum and minimum principal stresses. At the same time, we can calculate the maximum shear also. Okay, okay. So this is the way of calculation of variables. What are the variables? Principal plane, principal stresses, maximum shear. What is the relation between the normal stress and shear stress and maximum principal plane? We can calculate each and every value. So this is named as analytical method to calculate all the variables in complex state of stress. Now here I'm going to explain to you. So how to calculate these same values uh, by using Morse method now. That is also named as Morse circle method. It is also named as graphical method. Or you got my point or not? So I'm going to explain to you how to calculate all these values by using the graphical method. After that, I'm going to explain to you what are the principal strains. After that, I'm going to give you so remaining topics. Okay, right, listen carefully. So I'm going to write it here. That is Moore circle method. Moore circle method. So in the Moore circle method, they're asking questions in two ways. Listen carefully. Most of the any competitive exam, they're asking questions in two ways. First of all, they're asking question that is the Morse circle radius. Morse circle radius. And the second one is they're asking question first of all on this one. Like this. First of all, you'll ask Morse circle radius, and next one is nothing but coordinates of Morse circle. Coordinates of Morse circle. And the third one, draw the Morse circle diagram. Morse circle diagram for given state of stress. So this is the way of These are the 3 points we have to remember. So most of the questions are given on these three only. So in any competition, they're asking either draw the Mohr circle diagram or find the coordinates of the Mohr circle or find the circle radius. They're asking. Now, first of all, I'm going to give it to you how to draw the Mohr circle in different cases. What are the cases we have now? One is uniaxial, one is biaxial, one is shear, one is uniaxial and shear and biaxial and shear. I'm going to give it to you. So how to draw the Mohr circle. So I'm not giving the entire thing of this one. I'm going to give about these 3 points. So listen carefully. I'm going to give it to you how to draw the Mohr circle diagram for different cases. After that, I'll give some problems which are given in GATE examination also. Okay, right. So first of all, I'm going to give some important points to draw the Mohr circle diagram. So if you want to draw the Mohr circle diagram for any case, whether it is uniaxial, biaxial, or like that, but remember the first point like this. First point is nothing but take two reference axes. Take two reference axis. So all of you know, so this is a vertical axis, this is horizontal axis. So this is x-axis, this is y-axis. These two are meet at one point, that is nothing but origin. Origin is nothing but 0, comma 0. Origin is nothing but 0, comma 0. And the second one is nothing but horizontal axis. Horizontal axis belongs to normal stresses. Belongs to normal stresses. That means if you see the diagram, this is the positive x-axis, this is the negative x-axis. This is the positive x-axis, this is negative x-axis. So we are going to indicate normal stress here, here normal stress here. But here normal stress positive. Normal stress positive means tensile. Normal stress negative means compressive. So if you take all positive stresses here, all negative stresses here. So all tensile forces are indicated in this direction. All the compressive forces are indicated in this direction. Are you got my point or not? So on third point, remember, so vertical axis belongs to shear stresses. So here is also we are having shear vertical axis. So upward direction shear is positive, downward direction shear is negative. So there are two shear, positive shear and negative shear, clockwise shear, anti-clockwise shear. So but both are having same magnitude but directions are opposite. So the vertical axis must be belongs to shear stresses. Or you got my point or not? So remember these 3 points. Depending on the 3 points, I'm going to draw the Mohr circle diagram for different cases. So take two reference axes, x and y, and a horizontal axis belongs to normal stress, but one side is positive tensile, one side is negative compressive, and the vertical axis belongs to shear. One side is positive shear, one side is negative shear. But these two axes are intersected at this point. That point is nothing but origin. Or you got my point? Right. So here I'm going to draw the Mohr circle diagram for different cases. So listen carefully. So they're asking questions. Draw Mohr circle diagram, radius of the Mohr circle and the coordinates of the Mohr circle. So here I am taking first one is nothing but uniaxial state of stress. Uniaxial state of stress. So in case of uniaxial state of stress, so this is the case I'm going to indicate to you. So listen carefully. So this is uniaxial state of stress. So this is sigma x. This is sigma x. So this is either positive or negative, but here I am taking positive. So you can take negative also, no problem. Or got my point or not? So here I am taking positive. So that I'm going to draw the Mohr circle diagram to find the first one. How to draw the Mohr circle? Second one, what is the radius of the circle? Third one, what is the coordinates of the circle? Or got my point or not? So at the same time, what is the value of the normal stress? what is the value of the shear stress also. So we can calculate all those values as same as in analytical method. So that here how many normal stresses? Two normal stresses, but only one normal stress, but that is positive. So if you draw the first of all two reference axes, I'm going to take only one axis, which is positive, that is x-axis. I'm going to take it and I don't draw the negative x-axis here. Why? Because there is no any compressive. If there is any compressive, so I can draw this line also. So I'm going to take this is the vertical plane, this is the horizontal plane, which is belongs to positive stresses. So here, this is the reference point. That is the reference point. I'm going to take this magnitude. For example, the sigma x is equal to 200 megapascals. I'm going to indicate up to this one. I'm going to indicate with a suitable scale. So up to this one is equal to how much? Sigma x. Sigma x, that is equal to how much? 200 megapascals. 200 megapascals. So I'm going to take this point is nothing but A. This is nothing but O point, origin. I got it. So this point is nothing but O, origin. So this point is O and this point is A. Now I'm going to divide the line OA into two equal parts. So please listen the procedure. First, what I'm telling, draw the two reference axes. Depending on the diagram, we can take positive x-axis or negative x-axis. If one is positive, one is negative, take the both axes along the x direction. So here we are having only positive. So I can take positive x-axis. Are you got my point or not? Right. So two things is clear now. Take the two reference axes and indicate the stress on this axis, that is here tensile, and divide that line OA into two equal parts. OA into two equal parts. That point is I'm going to take as B. So if you divide if you divide this line into two equal parts, then we are getting like this. So what is this value here? What is this value now? Tell me. So this value is equal to sigma x by 2. And this value is also up to this one is also is equal to sigma x by 2. Or you got my point or not? Or you got it? Right. So here I am taking B as center. I am taking next point B as center and B as radius. This is the radius. And this one is also same. So B as center, B as radius or OB as radius. So I'm going to draw one circle here. I'm going to draw one circle here. So this is nothing but more circle diagram for uniaxial state of stress, but is it tensile? If it is compressive, this entire diagram is come to this side. Or got my point or not? If it is compressive stress, then this entire diagram is turns this side now. So, or you got my point or not? Now, here I want to find the what is the radius of this Mohr circle. Now, tell me here, anybody here, what is the radius of the Mohr circle? This is the radius of the Mohr circle. I am writing here radius of radius is equal to how much? AB, but AB is equal to how much? Tau x, sigma x by 2. But what is this value? So what is this value? So this value is nothing but radius. But this is also named as, if you draw one line here, and this value is tau maximum or not? Tau maximum or not? So this is the tau zero, and this one is point is, if you extend this line like this, then this value is nothing but tau maximum. So I can write this sigma x by 2 is also radius. It is also is equal to tau maximum. So in Mohr circle diagram, the radius of the Mohr circle must be is equal to radius of this circle is equal to tau maximum. Or got my point or not? Now I want to draw one plane here. So here I'm going to draw one line here. That line makes an angle of how much? 2 theta. This this is not a line, it is a plane. But here in the diagram, I am going to draw one line which makes an angle of 2 theta. That line intersect the circle at one point. That point is named as P. That point is named as P. P is always named as state of stress. P indicates state of stress. What is the meaning of this one? What is state of stress? If you extend one line, so see this one. This is a point, nothing but point. State of stress is nothing but this is a point on which plane? XY plane. So I am taking this is X, this is Y. Now what is the value of X? If you draw one line perpendicular to on X axis, if you draw one line perpendicular to Y axis, so we are having this is the vertical distance and this is the horizontal distance. I got the point or not? So if you draw one line perpendicular from P perpendicular to OA, then we can get this value is nothing but C value. I'm indicating C here. Okay. So I am writing like this here. Now tell me that is right or not. P state of stress means, for example, listen carefully. If it is a XY plane, if you indicate one point, that point having X comma Y. The X is nothing but which one? X is nothing but horizontal line. Horizontal line is belongs to normal stress. So X is belongs to normal stress. And the vertical line is belongs to which one? Shear stress. So P indicates state of stress means what is the value of normal stress? What is the value of shear stress? On which plane? This plane is nothing but makes an angle of 2 theta. The plane is named as oblique plane. I have already told you in analytical method. We are always taking in a plane. That plane is always oblique plane. On that plane, we are having two types of stresses. One is normal stress and one is shear stress. So here I am writing. Now I am writing here OC. OC. This one is OC. This OC is always belongs to which one? Normal stress. Normal stress. We can indicate with the scale. We can measure by the scale also. So here, what is PC here? PC is nothing but shear stress. Shear stress. On which plane? On oblique plane, which makes an angle of which one? 2 theta. Or got my point or not? So if you join these 2 points, so here is normal stress, here is shear stress. This is tau and this is normal. If you join these two, we can get resultant or not? You can get resultant or not. So I'm going to join these 2 points now, like this. So this is nothing but sigma. So I'm writing here OP. OP is resultant stress. OP is resultant stress. So this is the way of drawing uh, more circle diagram for uni-axial state of stress. So what is the radius here? Sigma x by 2. Now anybody tell me what is the coordinates of the circle? Coordinates of circle means center of the circle. What are the coordinates here? Now tell me on the x-axis, this is the coordinates. B coordinates I am asking. B coordinates. What are the coordinates of B now? From this point is x. X is nothing but sigma x by 2. But on the horizontal line, y is 0. So I am writing here coordinates. Coordinates of Mohr circle must be here sigma x by 2 comma 0. Sigma x by 2 comma 0. So all points are clear. So you have to take care about if it is compressive stress, this diagram is entirely come to this side. Or got the point or not? If it is tensile, we can draw like this. So this is for uniaxial state of stress. This is for uniaxial state of stress. So radius of the circle is given. So check it. This is same as in analytical method. This is same as in analytical method also. In uniaxial state, radius uniaxial state, tau maximum is equal to sigma x by 2. But here it is named as radius of the Mohr circle. Remaining all are we can find it. P is the number state of stress, that is on an oblique plane which cuts the circle at one point, that is P is equal to sigma and tau value. We can calculate sigma n value. See this one, we can calculate this length. We can calculate this length. What is up to this one here? Sigma x by 2. And we can calculate this one by using this triangle. By using this triangle, then add those two, then we can get the sigma n value. So they never ask those values, the derivation part. There are totally give the values, then substitute, then take the measurement of those points, then we can get the required values. Okay, right. So this is for uniaxial state of stress for Mohr circle diagram. Next one, I'm going to give it to you biaxial state of stress. This is very, very important also. So I'm writing here biaxial state of stress. Biaxial state of stress. So listen carefully. In biaxial state of stress, I'm going to first of all indicate the diagram. So this is a state of stress. This is sigma x, sigma x, sigma x. This is sigma y. Right. So I want to draw the Mohr circle diagram, and I want to find the Mohr circle radius. I want to find the coordinates of the Mohr circle. I want to find normal stress, shear stress, the shear plane, everything we can find it. But in competitive exam, they are asking, most of the questions are asking on these 3 points. So remember carefully. Radius of the Mohr circle, coordinates of the Mohr circle, and how to draw the Mohr circle diagram. So in this way, in this here, sigma x positive and sigma y is also positive, or you got both are tensile, so that, but here sigma x is greater than sigma y. Sigma x is greater than sigma, we can tell sigma y is greater than sigma x also as you wish. So anyone is more than other one. So here if you see this one, there is no any negative value, all are positive values, so that I'm going to take, this is the reference line vertical and this is the horizontal line. Or you got my point? Right. This one is nothing but origin. Or you got it? So first of all, I'm going to take sigma x. Sigma x is maximum. So I'm going to take up to this total length. I'm going to indicate as sigma x value. For example, sigma x is equal to 200 megapascals. Sigma y is equal to 100 megapascals. By taking this suitable scale on the graph, we can take sigma x value up to this one. So this point is I'm going to indicate as A. And now I'm going to take sigma y. Sigma y is less than sigma x. So I'm going to indicate up to this one. This is nothing but point B. So up to this one is nothing but sigma y. This is sigma y. So 2 points is here. Take the two reference axes and indicate the normal stresses. There is no any shear, but both normal stresses are positive. So that I am taking only positive x-axis. So I'm not taking the negative x-axis. I got my point or not? Right. So I know the point A, I know the point B. What is the difference between the point A and point B here? What is the difference between point A and point B? That is sigma x minus sigma y. Or you got it? Now I'm going to divide this AB line into two equal parts. Two equal parts. Then what is the uh, half of this value now? What is this value? This value is nothing but sigma x minus sigma y by 2. It is also sigma x minus sigma y by 2. Or you got my point or not? So I'm going to divide the AB line into two equal parts. Then I'm getting the point C. Then I'm getting the point C. So I am taking C as center, ACA as radius, or CB as radius. We can take any one. I am going to draw the circle here. I'm going to draw the circle here. Or you got my point? Or you got my point or not? So here, this is named as Mohr circle diagram for biaxial, but both are positive. If both are negative, we are getting this diagram this side. We are getting like this. Or you got my point or not? Or you got my point? So this is the Mohr circle diagram for both compressive stresses. This is the Mohr circle diagram for both tensile stresses. Or you got it? Now tell me here. Now tell me here. What is the value of Mohr circle radius? What is the value of Mohr circle radius? So what is the value of most circle radius? This is AC. Radius is equal to AC. That is also is equal to tau maximum. So this is tau maximum. Now tell me what is the value of tau maximum? Tau maximum is nothing but how this value is equal to how much? That is sigma x minus sigma y by 2. Check it. In an analytical method also we got it. Sigma tau maximum in biaxial state of stress is nothing but sigma x minus sigma y by 2. Are you got my point or not? Right. Now I'm going to write it. Second one, coordinates. Coordinates of the circle. Now tell me, coordinates is nothing but x comma y. X comma y. So this is the center. What is the distance between these 2 points? Now tell me here. So up to this one is, that is x is nothing but, I'm writing, x is nothing but OB plus BC. OB plus BC. What is OB here? Sigma y plus BC. BC is nothing but sigma x plus sigma y by 2. Then we can get sigma x plus sigma y by 2. We can got it. Now, what is y value? On the x-axis, y becomes 0. Then what are the coordinates of the circle here? Coordinates of the circle is sigma x plus sigma y by 2 comma 0. Those are the coordinates of the circle. This is the Mohr circle diagram. This is the radius of the Mohr circle. This is the coordinates of the Mohr circle in biaxial state of stress, but both are said to be tensile stresses. Now remaining procedure is same. Draw one line here, so which makes an angle of 2 theta and it intersect at one point, that is P. P is nothing but state of stress. This is the state of stress. This is the state of stress. Or you got my point? Now, if you draw one vertical line from point P on the horizontal line, this is nothing but Q. And from this point is entirely normal stress. And this one is nothing but shear stress. If you join these two, we can get the resultant stress. This is resultant, this is shear, and this one is nothing but normal stress. This one is nothing but normal stress, sigma n. So what is resultant stress? We know that resultant stress is equal to square root of normal stress plus shear stress square. We know very well. Or you got it? So we can write here now. So what are the values here? That is PQ is shear stress and OQ. OQ is normal stress and OP is nothing but resultant stress. OP is nothing but resultant stress. And AC is nothing but radius of the Mohr circle. And these are the coordinates of the Mohr circle. And this is the Mohr circle diagram. So all are clear. Okay. All of you got it. I hope all of you understand this one now in biaxial state of stress. In case of all compressive, we can get the diagram in this case. If one is positive, if one is negative, I will give the explanation also later. So procedure is same, but only diagram will change a little bit now. Got my point or not? For example, see this one. I'll give it to you. So here, when sigma x and sigma y both are positive, sigma x and sigma y both are negative, and sigma x is positive and sigma y is negative. What happened? What is the diagram of Mohr circle? So in this case, Mohr circle diagram is like this. So when both are positive, this is the Mohr circle, this is center. And in this case, both are negative means then we are getting the circle like this. So this is the center of the Mohr circle. And in this case, one is positive, one is negative means, so up to this one, we are getting this circle. So up to this one is 0, and up to this value is nothing but sigma x, and up to this value is nothing but sigma y. Why? Because sigma y is negative, sigma x is positive. So then we can take this value is A, this value is B, divide this line AB into two equal parts. Then we are getting this is the center of the circle. This is the center of the circle. Or got the point or not? When we get like this, when sigma x is greater than sigma y. Sometimes sigma y is greater than sigma x also. If sigma y is greater than sigma x, then the center will lies at this point. Or got the point or not? Or you got it? Right. I will give the more explanation in solving the problem. So when they are giving sigma x value, sigma y value, and how to draw the motorcycle diagram. I'll give it to you. So this is the case of biaxial state of stress, how to draw the motorcycle diagram. Now in third case, I'm going to explain to you. So how to draw the motorcycle diagram for pure shear. How to draw the motorcycle diagram for pure shear. So motorcycle diagram for pure shear. So for example, this is the case. This component is subject to a shear like this. So first of all, you have to indicate the shear on vertical. After that, we have to indicate on horizontal plane. So this is shear tau xy. This is also tau xy. This is also tau xy. So this is also tau xy. All are having same magnitude, but directions are opposite. We are always applying the shear on vertical planes. These horizontal planes applies complementary shear. That is nothing but equal and opposite shear is applied by the horizontal planes. So, but directions are opposite, but magnitude is same. So, in this case, how to draw the Mohr circle diagram here? So, here, this is the reference axis, x and y. First of all, we are going to take it. Listen carefully. This is the horizon. Now, if you take this is the vertical planes, which type of shear is acting on the vertical plane? Now, tell me, which type of shear is acting on the vertical plane, clockwise or anti-clockwise? For example, if it is clockwise. So why? Because it is clockwise. If you see in this direction, it is rotating in this direction. You got my point? So clockwise here, I'm going to indicate on this vertical line. This is plus tau xy. The point is here. So automatically, this horizontal planes always gives counterclockwise shear in opposite direction. So that is negative. So I'm going to indicate another point here, that is B. That is nothing but after this one is how much? Minus tau xy. This is origin O comma O. Now I'm going to divide this line AB into two equal parts, but OA and OB both are same. So here OA is equal to OB is equal to tau xy, but the plus or minus one is positive and one is negative. Both are having same magnitude, but directions are opposite to each other. So I'm going to divide this line into equal parts. So center of this line is origin. So I am taking OA as radius or OB as radius. I'm going to draw the circle. I'm going to draw the circle here. Have you got my point or not? Have you got it? Right. So this is the Mohr circle diagram for pure shear. Now tell me here, what is the radius of the circle here? What is the radius of the circle? What is the radius of the circle? So radius of the circle r is equal to tau maximum. It also is equal to plus or minus tau xy. We can take positive value, we can take negative value. That's why I'm writing plus or minus tau xy. And what are the coordinates here? What are the coordinates here? X comma y. So this is the center, that is origin. So coordinates is 0 comma 0. So in this way, we can draw the Mohr circle diagram for pure shear, and we can find the radius of the Mohr circle, that is always in terms of shear, and the coordinates is nothing but 0 comma 0. Why? Because this is the center of the circle. So center of the circle is here is nothing but origin of this two coordinates. Then we can find these three values very easily. Or you got my point or not? Right. This is for future. Remaining things are all same. Draw one line with an angle of 2 theta. That line always goes to intersect the circle at one point. Those things are not important, but here these 3 points are very important. So take care about those things now. Right. So three case is over, and fourth case I'm going to give it to you. listen carefully. When the component is subject to uni-excellent shear, and the last one is bi-excellent shear. So here I am taking the fourth case, that is uni-excellent shear. Uni-excellent shear. So here is I am taking sigma x positive and tau xy. We can take it plus or minus. So here this is the component. So I'm taking here. So this component is subject to a uni-axial state of stress like this, sigma x, along with shear here. So here I'm taking vertical planes and automatically the horizontal planes I will apply some stress here. So this one is how much? Tau xy, tau xy, tau xy, tau xy. I got it. Now here, what is our aim now? So how to draw the Mohr circle diagram and how to find the radius of the Mohr circle and how to find the coordinates of the Mohr circle. So first of all, I'm going to take two reference axes. So listen carefully. So there is no any negative value on x-axis. Why? Because only one tensile stress. There is no compressor. If it is a compressor stress, we can draw a line this side now. So I am taking here from this one is origin O and this point is A. So from O to A, I am going to take sigma x, that is normal stress value. So x-axis always belongs to normal stress, but here is along x sigma x tensile stress. That is the value of sigma x. Now here, uh, this is the uniaxial with respect to along with which one shear. So here vertical plane I am taking here. I am taking A point is belongs to vertical plane or O point belongs to horizontal plane. Otherwise, we can take like this. O point is belongs to horizontal plane or A point is belongs to vertical plane. So if A point is belongs to vertical plane, which type of shear is acting on the vertical plane clockwise? How much clockwise is nothing but we are going to indicate in upward direction. Why? Because shear is always in upward direction. Tau x, y. If O point is belongs to horizontal plane, so on the horizontal plane also, this one is nothing but tau xy. So this point is B and this point is C. I'm going to indicate, but both are having same magnitude, but directions are opposite to each other. Now I'm going to join these 2 points. Now I'm going to join these 2 points like this. If both are having same magnitude, this line exactly intersect the horizontal line OA at the center. So here, what is this value and what is this total value? What is this total value sigma x? Half of this value is equal to how much? Sigma x by 2. It is also sigma x by 2. So what is this? What is this value? This value is nothing but C, and I am taking as D. So what is OD, DA, OD or DA both are same, sigma x by 2, sigma x by 2. And what is AB, tau xy? We can take positive or negative, both are same. Or get my point? So it is like a right angle triangle. Or got my point or not? So I am taking here this point as center. So DA as radius. I am going to draw the circle like this. I'm going to draw the circle like this. Or you got my point? What I'm saying? D as center, D as center, DB as radius, or DC also radius. Now find what is this radius now. What is the value of this radius? DB. Now tell me here, what is the radius of DB here? So DB we can find very easily. That is, I'm writing here. So DB square is equal to DA square plus AB square by using this right angle triangle property. By using right angle triangle property. Is it right or not? So this one is dA is nothing but sigma x by 2 whole square plus tau xy whole square, whether it is positive or negative. So dB is equal to how much? dB is equal to square root of this value. Now, what is this value? This value is also is equal to how much? Radius of the Mohr circle. Radius of Mohr circle. Now, radius of the Mohr circle, if you rotate like this, rotate like this. So this is also named as maximum shear value. This is also maximum shear value. Or you got my point or not? So maximum shear and radius both are same. So tau maximum is equal to, so plus or minus, we can take either this side or this side. So I can write square root of sigma x by 2 whole square plus tau xy whole square. So this is the value of the radius of the Mohr circle. Or you got my point or not? So simply we can find the Mohr circle diagram, and we can find the radius of the Mohr circle also. And we have to find the what is the coordinates of the circle. That is very important here now. What are the coordinates of the circle here? So this is the center of the circle. I want to find the coordinates of the circle. Okay. Now tell me anyone what is the coordinates of the circle now for this case. What are the coordinates of the circle here? So that is circle D, that is equal to x comma y. So this is the center. So this is the origin. So from the origin to center, what is the value here? Sigma x by 2. Sigma x by 2. This distance. And what is the y value on x-axis? 0. So this is the value of coordinates of Mohr circle. Coordinates of Mohr circle. Are you got it? So in this way, we can calculate Mohr circle radius and the coordinates of the Mohr circle, and the remaining process is very simple. Take one line, or you can draw one line which makes an angle of 2 theta, and that line goes to intersect the circle at 2 points. So you can draw one vertical line from intersection point to horizontal and join those. Then we can get the resultant as same as in the previous case. I already explained to you. Or get to point or not. So this is the way of drawing Mohr circle diagram for uniaxial shear. Now the last one is a very important case, that is biaxial shear. Biaxial shear. So here I'm writing biaxial shear. So listen carefully. So biaxial shear case. In biaxial shear case, I'm taking sigma x is positive and sigma y is also positive, and tau xy is we can take plus or minus, that is positive or negative here. So here, this is the, here also I am taking sigma x is always greater than sigma y. Sigma x is greater than sigma y. Or you got my point or not? So this is the indication of the state of stress on a component at any point on the component. So this is the state of stress. This is sigma x, this is sigma y, this is shear, 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 shear. This is tau xy, all are same. So here I'm going to draw the Mohr circle diagram for this case. So listen carefully here. So this is the horizontal line. Okay, right. This is the vertical line. This is the vertical. This is horizontal. This is origin. O 0 comma 0. That is origin. Right. So first of all, I am taking this sigma x positive. So first of all, I'm going to take from this point to this point, this entire length. This entire length is belongs to sigma x. That is along x direction. And sigma y is always less than sigma x. So I'm going to take up to this one is sigma y. Up to this one is sigma y. Now, what is the remaining value here? Remaining value is nothing but sigma x minus sigma y. Listen carefully. Sigma x minus sigma y. Right. So this is the point A. I'm going to take it. This is the point A, and this is point B. Or you got it? This is point A. This is point B. But also here, two normal stresses is clear. So I'm going to indicate shear stress so that this point A, point B, I'm going to take one is vertical plane, one is horizontal plane, as same as in the previous case now. So I'm taking point A is vertical plane. So on the vertical plane, which type of shear is acting here? Clockwise. So it is positive. So I'm going to take one line here up to this one. This one is nothing but C. This one is plus tau xy. And point B also having negative shear. So this one is nothing but D. It is negative tau xy. All you got it? Now I'm going to join these 2 points. If these two values are having same magnitude but directions are opposite, then this line BC exactly intersect the horizontal line at center. Or got my point or not? Now tell me here, this point is E. Now tell me what is this values? What is this value? And what is this value? Both are same. Now tell me what is that value here. So this entire length is nothing but sigma x minus sigma y by 2. Half of that value is nothing but how much? This value is nothing but sigma x minus sigma y by 2. This value is also same. Now I know this value. I know this value sigma x minus sigma y by 2. I know this value tau xy. I want to find this value. This value is nothing but which one? Hypotenuse generally. But here, this is the center I am taking. This is the center I am taking. I am taking EC as radius or ED as radius. I am going to draw one circle here. I am going to draw one circle here. Are you got it? So this is the Mohr circle diagram for biaxial and shear. This is a Mohr circle diagram for biaxial and shear. Now here, this is the radius of the circle. Why? Because I am going to draw the circle with respect to this one. Now, how to find this radius here? We can find very easily the radius of the circle. So now tell me here, anyone, how to find that radius here now. So radius, I'm writing here, radius, that is nothing but EC, E is equal to, that is EA whole square plus AC whole square under square root. Under square root. Or you got my point? Right. Now tell me here. Now tell me what happened here. What is EA? EA is nothing but sigma x minus sigma y by 2 whole square plus what is AC? AC is nothing but tau xy square under square root. So this is the value of radius of the Mohr circle. So first of all, we have to learn how to draw the Mohr circle. And after that, we know that how to find the radius of the Mohr circle. It is also is equal to how much? Tau maximum. This is the tau maximum value. This is the tau maximum value. It is also is equal to radius. It is also is equal to how much? Radius. Now, how to find the coordinates of the circle? So here, coordinates, I want to find the coordinates of the circle. X comma y. Now tell me what is the coordinate circle x comma y here. So here, this is the center of the circle. I want to find this distance here. What is the distance now? This one is OB plus B. So I'm writing here x is nothing but OB plus B and y is nothing but 0. What is OB here? What is OB here? OB is nothing but sigma y. See this one. OB is nothing but sigma y plus What is BE? BE is nothing but sigma x by 2, sigma x minus sigma y by 2. This one and this one both are same. So I'm writing here sigma x minus sigma y by 2, comma 0. Then what we get, if we solve this one, take the LCM, then we can get sigma x plus sigma y by 2, comma 0 is the value of coordinates of the Mohr circle when the component is subject to biaxial and shear. I hope you understand very well. So how to draw the Mohr circle diagram and how to find the radius of the Mohr circle and how to find the coordinates of the Mohr circle. At the same time, we can find all those values, what I told you in analytical method, we can find all those things. But here, an examination point of view, these 3 points are very, very important. So you have to take care about those things now. Or you got my point? Right. So these are the more circle diagram for different cases. That is uniaxial, biaxial, pure shear, uniaxial and shear, and biaxial and shear. Now I want to give it to you some problems. How to find the radius of the Mohr circle and how to find the coordinates of the circle, which are given in gate examination. I'll give the simple problems for 1 mark. So which are given in examination only. Okay, so take care of it. After that, I will give the explanation about the principal strains, small introduction about the principal strains. After that, I'll, the next class, I'll give the explanation about the total explanation about the principal strains, how to calculate the strain values. After finding the strain values, we can calculate the stress values here. Now, see this one here. So here they are given the question like this. So an example question like this. So this is the diagram is given, and this one is the Mohr circle diagram is given, right? So this value is here. After this one is minus 10 megapascals, and here is given minus 100 megapascals. So this is the given diagram in the gate examination. So now tell me, anyone, what is the value of maximum shear and what is the value of radius of the Mohr circle? So both are same, maximum shear and radius of the Mohr circle, both are same. But questions they are asking, what is the radius of the Mohr circle? Question is, radius of Mohr circle, and the second one is coordinates of Mohr circle. Are you got my point? Are you got it? Two questions I am asking here. What is the radius of the Mohr circle and coordinates of the Mohr circle? So please try to solve it and tell me the answer also. But here I'm going to give the explanation how to find radius of the Mohr circle. So this is the circle, and what is this length here? We can get minus 90 megapascals. And the center is how much? What is the center here now? Center is nothing but how much? This is. So I'm writing here radius of Mohr circle must be is equal to how much here? That is minus 100. Actually, we know the formula. Minus 100, that is tau maximum, is equal to, we know very well, that is minus 100 minus or minus 10, then we can get 90 minus 90 divided by 2, then we can get minus 45 megapascals from this circle. Or you got my point? All of you got it? Right. So here, what are the coordinates of this circle here? Coordinates is nothing but you have to calculate from this point, origin, O comma O. We have to calculate from the origin. So what is the distance between these 2 points now? That is x. So I'm writing here coordinates x comma y, coordinates x comma y. So is equal to how much here? What is the x value here? X value is nothing but this total. Up to this one is how much? Minus 10. After this one is minus 45. So minus 10 minus 45 comma 0. So there is no y on x-axis. Y value is 0 on x-axis. So here, what is the value you get? Minus 55 megapascals comma 0 is the coordinates of the Mohr circle. Or you got my point? Coordinates of Mohr circle. Or you got or not? Right. So one more question is given. So on this radius of the Mohr circle. Right. So all of it clear up to this one. Coordinates and how to find the radius of the Mohr circle is clear. So now I'm going to give it to one or two problems on this Mohr circle diagram. Please take care about those things now. So here one question is given. So sigma x equal to sigma y. This is the question is given. Sigma x equal to sigma y. So this is the case of and the tau xy must be is equal to 0. Which case it is now generally? So this case is belongs to biaxial and biaxial only, because the shear is 0. So here asking draw the Mohr circle diagram and find draw the Mohr circle diagram. And the second one is Mohr circle diagram. And second one is radius of the Mohr circle diagram. Radius of Mohr circle. Now, how to draw the Mohr circle diagram here? So, first of all, we are going to take two reference axes. So, here x and y. But here, sigma x must be is equal to sigma y. Both are same. So, I am taking this one is here, this one is point A. So, up to this one is I am going to indicate as sigma x, and the sigma x is also is equal to sigma y. So, both are equal. So, there is no any difference between sigma x and sigma y. So that what is the radius here? It is always indicates a point here. There is no radius. There is no radius. Are you got my point? Sigma x, sigma y both are indicate one point. There is no any difference between that sigma x and sigma y. So sigma x, sigma y both are indicate one point. So the radius must be is equal to how much? 0. And the circle, it never indicates a circle. It indicates a point on the horizontal line. It indicates a point on horizontal line. Or you got my point or not? Or you got my point? So this is the Mohr circle, but this circle indicates a point. Circle indicates a point, and the radius of the Mohr circle must be is equal to how much? 0. Or you got my point? Right. So here one more question is also is given. So listen carefully like this. This question is given like this. This question is given, listen carefully. This is nothing but 30 megapascals, and this one is 5 megapascals, and this one is 5 megapascals, and this one is nothing but 20 megapascals. This one is given like this. So this is nothing but we have to remember the if any problem is given like this. So first of all, I'm going to explain to you. We are going to express the normal stress and shear stress or normal strains or shear strains in terms of a matrix that is nothing but a tensor. That is nothing but tensor. Nothing but tensor. Okay, we can write here stress tensor or strains tensor. There are 2 points are very important. I have already told you in the chapter number 1 in two-dimensional, three-dimensional. I have given to you. So here this one is equal to sigma x. This one is sigma y. This one is tau xy. This one is nothing but tau yx. That is right, tau yx. I got my point or not? So both are having same magnitude, but directions are opposite to each other. Or you got my point? So they will give the question like this, but they are asking the question, find the radius of the Mohr circle or find the maximum shear. So they are asking question, radius or tau maximum value. So how to find this one by using this matrix? This is named as a state of stress of a component. That means there must be a sigma x, there must be a sigma y, there must be a tau xy. So it is belongs to which one? Biaxial and shear. Biaxial and shear case. So in biaxial shear case, what is the value of tau maximum? We know that that is sigma x minus sigma y by 2 whole square plus tau xy whole square. Are you got it? Otherwise, we can draw the more circle diagram. We can find easily. So then I can write here plus sigma x is nothing but 30 minus 20 divided by 2 whole square plus 5 square under square. So this one is 10. That is 5 square plus how much? 5 square under square root. Then we can get 25 plus 25 under square root. Then we can get 50. Then 25 into 2. Then we can get 5 root 2 is the value of radius. That is in terms of megapascals. Or you got it? So they will ask questions like this. Okay. Otherwise, they will ask question like this. In gate point of view, one question is given. And the same way, they will ask questions one or two on the same way. They will be the three-dimensional, two-dimensional also. In some cases, they will give like this. This value becomes zero, and this value becomes zero. If it is zero, it is belongs to pure only biaxial state. It belongs to only biaxial state. Is it right or not? If there is any shear value is given, so it belongs to biaxial and shear. Or got my point or not? Biaxial and shear, depending on the matrix also. I have already told you in the chapter number 1 how to indicate the state of stress or stress tensor and strain tensor. This is the stress tensor in the biaxial and shear. Or got my point? We can indicate the normal stresses and shear stress in a matrix form that is named as tensor. So by using the tensor also, we can calculate radius of the Mohr circle or maximum shear and coordinates of this Mohr circle diagram. We can find any value here. Okay, right. So this is the way of calculation of Mohr circle diagram. So first of all, if any question is given on a complex state of stress, you want to find the maximum and minimum principal stresses. So we have to identify first of all that problem is belongs to which case. That the problem is belongs to which case, whether it is uniaxial or biaxial or shear or uniaxial and shear or biaxial and shear. Then only we can calculate all the values. What are the values we have to calculate? So that is nothing but um, principal plane, principal stresses, shear plane, maximum shear, and the resultant shear. We got it? So this is the way of drawing the Mohr circle diagram. So in different cases. So if you want to draw the Mohr circle, identify the case only. Then only we can draw the Mohr circle diagram. You got my point? Right. I hope you understand very well. If you have any doubt, please note it down. Your doubts at the end of the class, we will ask it now. No problem. You got my point? Right. So next topic is nothing but a simple introduction about the strains now. That is nothing but uh, principal strains. Principal strains. Up to this one is stresses is over. So now our topic is I will give the explanation tomorrow. Tomorrow on this one, principal strains. In case of principal strains, formulas are same as in principal stresses. So what are the general formula of stresses here? We can write normal stress, shear stress. But in case of principal strains, normal strain and shear strain. The phi is belongs to shear, epsilon is belongs to strain. That is n is normal strain, phi is shear strain. So I'm going to replace sigma x is replaced by epsilon x and sigma y is replaced by epsilon y and tau xy is replaced by phi xy, but this phi xy is always equal to gamma xy by 2. So that is the linear strain is always equal to half of the shear strain is equal to half of the linear strain. So then we can substitute this value in the all the formula, then we can get the required value. So I will give the explanation tomorrow how to calculate strains. After calculation the strains, I want to give it to you what is the relation between the stress and strain in one dimensional, in two dimensional, and three dimensional. That is nothing but relation between the principal stresses and strains. So if you want to calculate the strain is nothing but deformation. Strain is nothing but deformation. Deformation can be calculated by some devices. Those are named as gauges. I can arrange those gauges in a particular direction. Those are nothing but strain rosette. I'll give the explanation about strain rosette. So tomorrow, so please take care about this completed portion. So be practice all the um, previous questions or any other questions in any other books. Please try to solve and solve more problems and thorough about the concept. Then you will get the confidence to attempt any question on principal stresses and strains. Okay. Thank you very much. Thank you to support me. So tomorrow we will meet. So thank you. Thank you all of you. Thank you. Thank you. Thank you very much, all of you.